All right, hello everybody. Thanks for coming. Um, my name is Kendall Thrapp, and I'm with Yahoo's Grid UI team. We're a small team with a focus on capturing grid-related metrics and building web applications and tools to help all the users and admins of our entire Hadoop ecosystem. Today I'm going to talk about our journey to add cost and resource tracking to our Hadoop clusters and then eventually to our Storm environments as well. So many small Hadoop clusters can kind of be like a self-sustaining community in that, sure, individual users have their own needs and wants, but for the most part, they can be expected to figure out how to share those resources for the betterment of the whole. And after that, we've got queues and user limits to help manage things when it gets a little more complicated. But at Yahoo scale, our clusters are more like a sprawling metropolis, or perhaps like this busy Bangladesh street. We have over 3,000 different Hadoop users spanning roughly 600 different projects, all running over 1.2 million apps every single day across our clusters. Now, individual users and teams are keenly focused on meeting their own SLAs, but they're not necessarily thinking or caring about how their usage impacts everyone else. Essentially, we've grown beyond the bounds of a community that can be reasonably expected to fairly share resources on their own. And we've grown beyond on what can just be simply controlled through queues and user limits. So how can we ensure fairness, ensure that all of these many different needs are met? To answer that question, we first started with what at the beginning seemed like a simple question: how much am I using and what does it cost? But let's step back from that for a minute and just spend a minute to talk about why we should put any of our valuable engineering time and effort into capturing and analyzing resource utilization metrics. First up is capacity planning. The ability to see these trends over time helps us better predict future resource shortfalls and actually be proactive about getting more resources in place before that happens. And to give the Yahoo perspective, our clusters aren't elastic cloud environments. These are owned and operated clusters, and very large clusters with fixed sets of machines. So adding machines is a pretty lengthy process of ordering, getting things installed in racks and so forth. So we really want to be able to get ahead of the game. Next is operational efficiency. These kind of resource usage metrics can allow us to actually benchmark applications from a resource perspective and actually quantify how software changes affect platform usage and cost. In other words, we wanted our teams to be able to see how their platform usage, absolute numbers and cost changes from each of their software releases to each of their software releases. And on the platform team side, we want to be able to see how everyone's cost changes from platform release to platform release. And being able to put a cost to all those things helps provide a business justification for the times when it makes sense to actually spend time engineering more efficient software instead of just throwing more nodes at the problem. And I'll give an example of that later in the talk. And of course, there's profitability and return on investment. Simply put, if the project can't quantify their cost of the Hadoop platform, then how can they possibly know what their total project cost is? And without that, how can they know, how profitable they are? So being able to put a dollar cost for every project's usage of our Hadoop platforms, it just helps Yahoo make better business decisions and have a fuller understanding of its return on investment for each of its projects. Fourth is the efficiency of the platform itself. So being able to track cluster and queue level utilization over time allows us to be smarter about where to onboard our many new projects, move existing projects, or even shuffle resources back and forth between the clusters and queues, all in order to maximize the overall platform efficiency. Last but not least is transparency, making everyone's use of the platform visible to everyone else, all 3,000 of those users, helps ensure fairness and accountability because we can all see who is and isn't using and funding their fair share. But in spite of all that, tracking resource usage in Hadoop was really hard. Now, if you're really familiar with Hadoop, which I'm sure many of you are, you might be thinking, well, but we have job counters for that. Sure, for the MapReduce type applications, there's always been some job counters, map slot millis, reduce slot millis, to help with these kind of resource calculations. But they're a little bit tricky in that they don't always capture all the resources used by an application. For example, if the app needed to reattempt, that the resources used by that earlier attempt don't get included. Also, they're a little bit tricky to use in that they kind of require some knowledge of some archaic things like what's a slot and how big is it for my particular cluster. So just in general, over the years, I've seen a lot of experienced Hadoop developers misuse and miscalculate based on these metrics. So in the same way that, almost every modern car now will show you your gas mileage right there on the dashboard, we thought that being able to see your usage of the Hadoop platform should just be really easy. It should just be an intrinsic part of the platform, no matter how you choose to use it. Which is a key point, because coming back to those counters, they didn't exist at all for the non-MapReduce type applications, and we're heavy users of Tez, Spark, and Slider. So 3 years ago, we set out on a mission to be able to do just that, to make it easy. We came up with a method to be able to calculate resource usage at the individual Yarn application, as well as being able to see a timeline of resource usage at the cluster, queue, and individual user level. And finally, we were able to turn those resource usage numbers into a dollar cost through a cost model we developed. So before I go any further, I want to sync up real quick on the language of grid resource usage. So your usage of the grid is a function of both the magnitude of a resource you used and how long you used it. So that means the unit for memory is something like gigabyte hours or megabyte seconds, and CPU, it's vCore hours or vCore seconds. This should seem kind of familiar because it's, you see this every day on your electricity bill in kilowatt hours. So just to give a quick example, if you have one 2 gigabyte mapper running for 5 hours, then you consumed 10 gigabyte hours of memory. If instead you ran 5 2 gigabyte mappers for just 1 hour, then you still at the end of the day consume that 10 gigabyte hours. Now this is great. It's a concrete billable number we have for that application. And we can aggregate all your apps and have that nice total. But as I'll get to later, it doesn't give us the full picture we need for all of our purposes. So way back in 2013, I proposed Yarn 415 as a way to capture aggregate resource allocation up at the Yarn application level. If it was up to each of the individual application types, we'd just never be able to get it done. If it was up to Tez and Spark and Slider and every custom Yarn application type someone made, we'd probably always be trying to get that full picture of usage. So this approach was to move it up to the Yarn level, so that no matter what kind of application you run, we get your resource usage and get it in the same language. The feature was pretty complex. Took I think about 1.5 years to commit through the hard work and perseverance of several Hadoop developers. And I especially want to call out Eric Payne at Yahoo for all of his hard work on this. It finally got deployed to the last of our clusters last June. So since then, anytime someone launched an app on any of our clusters, then Hadoop's own UI and REST API would report back at least the compute resources used by that app in megabyte seconds and vCore seconds, even while the app was still running. And that was kind of a key improvement, because being able to see that usage while the app is still running was something we never had before. You can imagine it's really important for those long-running apps. Sometimes we have apps that span days, and if you're trying to track that usage over time, then having 5 days of constant running just show up as a giant bomb at the end it really makes it hard to do your capacity planning. So our team captures this kind of information for every application run on any of our clusters. We store it off long-term in a database, and we make it available internally through REST API and a set of different web applications, like our Grid Dashboard UI and our Hadoop Apps dashboard, where people can see a history of any apps they've run, as well as how much resources they consumed and what the cost was. But as I alluded to earlier, that really only gives us the half of the picture. We know how much you consumed, but we don't know how that usage was spread out over time. And more importantly, we want to see how everybody's usage spreads out over time, all stacked on top of each other, so we can see the points of greatest and least contention over queue and cluster resources. So to that end, we sample cluster, queue, and user level compute resource utilization. We do it once a minute. We found if we do it less frequently, the picture gets too coarse. There's not enough detail. But below once a minute, there's just not much benefit other than a lot more data to store. So we make it available, again, through REST APIs and a web application we've created called our Grid Utilization Dashboard. So this allows our users to drill down through utilization at the cluster, queue, user levels, and kind of see their memory usage side by side with their CPU usage, with the number of apps and the number of containers, and look at any arbitrary time range in the past. So it's easy to go back and see, well, how much did we spike up to last year at Black Friday? We further aggregate this at different levels, hourly, daily, and monthly. So it's easy to, at this point, we can pick a user and see their utilization in one chart over a 3-year span. Also in Yahoo, we have a web application we call Doppler for our cloud project forecasting and tracking. So through our Doppler application, our projects can see a rolling 1-year history of their compute resource usage. There's a lot going on here in the slide, so I'll step you through it real quick. There's a table at the top where we show on the right side the current average usage for each resource for the current month. And to the left of that, the previous 3 months. We also show their current approved quota. So it's easy to see at a glance, a general upward trend, or if they're over their limit, which is the case for this project. Below that, we've got 2 rolling 1-year historical charts. The blue one on top is for memory, and the orange one on bottom is for CPU. Now that grid utilization dashboard I mentioned earlier, that's where we dig down into the nitty-gritty, whereas this view is more to give the high-level day-to-day changes. So there's 1 point per day, and the solid line in the middle is the average for that day. And it may be hard to see on the projector, but there's an inner darker band around that line, which is the average plus or minus 1 standard deviation, and a lighter band around that, which is the observed min and max for the whole day. So the standard deviation helps us with 2 things. It helps us give us an estimate of where their utilization fell the majority of the time throughout the day, and helps characterize their workload. Was it relatively constant, or does this project have more wild swings in their resource needs? As you can imagine, it's pretty easy to plan around those projects with relatively constant resource needs, but projects with wild swings are much harder to figure out how to slot them into a queue and figure out the right queue size so they can get what they need, but you're not wasting a ton of resources when they don't need it. There's a dashed orange line that shows their current quota, so we can see on a day-by-day basis when the project was above or below their quota. And all this is kind of intended to be actionable. So right there in the same app where you go to see your usage, it's the same place where you'd go to start the process to get more quota with that blue button up at the top of the panel. Now this panel is for the project's usage of an entire cluster, but we have a panel just like this for each queue they use, so you can see the same level of detail and take action in the same way to request a change in your queue quota. So up until this point, I've really only talked about compute usage, but we of course care about storage a lot as well. But since it's not subject to the same minute-to-minute wild swings that we see in the compute side, and it's more costly for us to capture, we get this about once every 6 hours, but we do it for every user and every top-level project directory across our clusters, which, given our number of projects, is actually quite a bit. So we show different separate areas for disk and namespace, with a gauge showing the latest reading for each resource. And the color of the gauge changes from green to red as the utilization approaches 100%. Hopefully to be a giant clue to our users that they're getting near the danger zone and they either need to, clean up or request more. To the right of that is that same kind of rolling 1-year historical chart like we saw in the compute section, where the blue area is the average per day, and there's the quota shown with the dashed orange line. So we actually get this data through HDFS proxy, and I forgot to mention on the last slide, we get the compute information through Yarn's Resource Manager Scheduler API. So that will give you back the amount of memory used in a particular queue, and even break it down by user in that queue. What it unfortunately won't tell you is the total amount of memory assigned to that queue. So if you want to be able to get that, you need to go to the Cluster Metrics API to get the total cluster capacity and use the percentage queue capacity to get the absolute number for RAM and CPU. So, the next step was to be able to turn those resource measurements into cost measurements. So through our total cost of ownership initiative in 2015, we began doing just that. We computed dollar cost for all of our compute and storage utilization for each of our projects. And on that Doppler application, we have a dedicated page for every project on each cluster it uses, as well as a top-level page. So we added in a panel like the one you see here on each of those pages, where we break down the cost per resource, as well as the total cost. So how do we do it? We first needed to come up with a total platform cost. And previous models tended to focus mainly on the cost of servers, but we wanted to have a more comprehensive picture. And so I'll go into the details of that in the next slide. But the next step was dividing that total platform cost by all the resources that we wanted to charge for. We chose an even distribution to start, so RAM, CPU, disk, and namespace each got 25% of that total platform cost. But we've designed it to be flexible so that we can adjust that distribution on a monthly basis and perhaps charge more for more scarce resources. So if CPU turns out to be plentiful on average and disk is what's really scarce, we might drop CPU down to only 20% of the cost and raise disk up to 30%. Now, I think the interesting part about this is that we divide the project's amount of a resource used on a particular cluster by the total amount of that resource used across the whole platform. And we multiply that by that total resource cost, that 25%, and what comes out is a dollar cost for that project, for that resource on that cluster. And of course, the total cost is the sum of all those resource costs. Now, you may have noticed I didn't say that we divide the project's resource usage by the total platform's capacity. We divide the project's resource usage by the total platform's usage, meaning the sum of everyone's usage, in order to be able to distribute the overhead and all that unused capacity cost across all of our projects. But distribute it proportional to everyone's usage. So if you're a huge platform user, then you're going to pay more for that overhead capacity. But you probably benefit more than the small guys too. So this means that at the end of the month, if we sum up our charge for each of the projects, then it always adds up to our total platform cost. So you can kind of think of it as we're running our private Hadoop platform as if it was a public nonprofit cluster. So coming back to that total Hadoop platform cost, like I said, earlier cost models really focused on just the cost of those compute servers. We'd say how many mappers and reducers do you need? Okay, that's going to be n servers. go ahead and get funding for that. With this approach, we wanted to take into account a lot of other cost factors that we hadn't really looked at closely before. So we look at the cost of network bandwidth that's transferred between our data centers. We look at operations headcount, so it could be our platform SC team members or the data center site ops folks. We also look at our platform engineering team. So we have a fantastic Hadoop engineering team that's making the platform better every day, and that's part of our platform cost. We also, of course, looked at the hardware, but we didn't just look at the compute nodes. We wanted to look at everything involved. So the resource manager, the name node, the gateways, the HDFS proxies, the load balancers, and all the networking hardware that wires all that together. And at the end of the day, we come up with a total platform cost and can see the distribution of those costs. Now, to be clear, this chart on the right here is not meant to convey Yahoo's actual total platform cost or the distribution of those costs. But what I can tell you is when we first did this exercise, when we just looked at the hardware cost, it was somewhere in the ballpark of that 60%. So those earlier, more naive models were kind of leaving behind 40% of the real cost. And of course, we want to be able to roll up this cost information on a variety of different dimensions. So we have what we call a TCO dashboard to be able to allow any of our users to slice and dice both the usage and the cost information along a bunch of dimensions like cluster name or cluster type, like we have sandbox clusters, research clusters, production clusters. You can do it by any date range or business unit. And sort on any of it. So it makes it really easy to answer questions like, well, who was the largest consumer of disk on this particular cluster this month? Or what are the most expensive projects in the search org in Q2? Does that really jive with what are the most profitable projects? And we sum up all those filtered results so we can also easily answer questions like, what's the total cost of the advertising org last quarter? So results. It's been just over a year since we rolled out the last piece of this. And through it, we've been able to unmask a variety of different hidden issues, like projects using far more compute resources than they were ever approved for. I can imagine this is probably one of the most common problems that people have. And we don't necessarily attribute malice or sneakiness to this. As I said, it's Hadoop hasn't made it really easy to see your resource usage. And maybe someone had a great idea coming in, what their resource usage was, but 6 months or a year down the road, as long as they weren't hitting any queue limits or user limits, they might not realize that their needs had doubled or tripled. So being able to have these metrics and visualize them really just, kind of shone the light on all those cases where this was happening. One particular example, we had a project that found they just weren't meeting their SLAs. And, probably naturally their first thought was, we must not be getting the resources that we funded. It must be these other guys that are, stealing in our resources. But through this, we're able to definitively show them that no, not only are you getting all the resources you funded, you're also getting another 4x that. So you guys are actually the ones that are perhaps stealing too much from everyone else. We also kind of saw the flip side of that, which was projects requesting more resources when they were actually underutilizing what they already had. You can imagine this comes about from someone. They did an estimate of what they needed, they onboarded, and sometime down the road they know that, well, my inputs are going to double or triple in size, so I'll just ask for double or triple what I originally asked for. With this, we could go back and say, actually, you don't need all that, and maybe your current quota can actually accommodate that future growth you see. Another fun one was finding some projects that were launching apps and queues that they weren't actually supposed to be using. This one I do attribute more to sneakiness. At the end of the day, we all have a job to do, and if we're finding ourselves not able to get that done in our queue, maybe some more enterprising engineers would look to see what looks not so busy and try and get something done there. So that's something we flag in our Doppler web application is projects using queues that they don't have any approved quota in. I think the most interesting one, though, was being able to find zombie projects that were, long canceled or retired, but continuing to consume grid resources. The most common case of this would be storage. Projects, maybe that data need to stay around for legal or contractual reasons for a while, but as time passes, it gets less and less likely that someone remembers to go back and clean it up. But more interestingly, through the marvel of automated scheduling with Oozie, we actually did come across a few projects that were still happily launching jobs, processing data, writing it off somewhere, even though no one knew that was still happening or cared that it was doing that anymore. And we were able to, there was one team we were able to go to and say, I thought you guys said this was, end of life. And they said, it is, we're not doing anything. And we could point and say, there's something going on there. You're still generating a load and some cost, and they're able to look into it and see, sure enough, there was one Oozie job that was missed when the project was cleaned up. I think another one of the really gratifying things, though, right out of the gate, was being able to help a team verify a significant reduction in their compute usage after they made a major efficiency improvement. Through their own estimation, they thought they were saving about 30%. So through this, we were able to immediately back that up and say, yep, we see that same 30%, but we could quantify it. We could say, not only did you drop 30%, but that amounts to tens of thousands of dollars a month. And 30% sounds great, but not as great as like $30,000 a month. And that helped be a driver for other teams to look at their own code and see if they could make that same kind of change and realize the same kind of savings. Nothing motivates people like dollars. So spurred on by all of this, we then turned to Storm and tried to apply a lot of the same techniques to our Storm clusters. So we sample RAM and CPU per topology per minute across all of our Storm clusters. We do this through Nimbus's topology summary REST API. And we aggregate it by user and by project. And like our Hadoop metrics, we make them available internally through REST APIs, but also we have a section in our Doppler application for Storm as well, where this should look very similar to what I showed for Hadoop, where we can show the current month's usage, that rolling 1-year historical chart compared to your quotas. And a lot of this is possible through the new resource-aware scheduler. So if you missed that talk and you use Storm, I encourage you to check that out, because we're now able to get back, not just workers and executors, but RAM and CPU assigned per topology. And just like we did on the Hadoop side, we came up with that cost model for Storm. We looked at all those different cost factors, and we computed that that per user cost using the user usage divided by everyone's usage of the platform. So to recap, it's been a journey to get here, but we can now compute resource usage for individual Yarn applications, as well as see a timeline for anyone's usage, at the user queue cluster, and even rolled up to entire project levels. And we now do the same for our Storm projects as well. And I really can't stress enough, the value in being able to, turn that resource usage into a cost, even though you're, even if you're running an owned and operated cluster. And you might be thinking, well, is it really cost savings? Because, you have a fixed number of machines. So it's not like if someone reduces their usage, that cost magically goes away. It kind of depends on your organization. We, given our scale, we have so many new projects coming online all the time, and so many existing projects needing to scale up, that if we weren't finding these cases where we could get projects to cut down on their usage, we'd be buying more hardware. So it lets us really squeeze as much as we can out of the equipment we have. So from here, we have a lot of places we'd like to take this. I think one of the things I'd like to experiment next is name node operations. We have over a dozen very large clusters, and it doesn't make sense to replicate all that data across all of our clusters everywhere. So, and ideally you want the processing to happen where the data is, but sometimes that's just not possible. And in those cases, we let our users maybe run the job in one cluster, but read remotely from another cluster if it's in the same data center. Now, today, we see that usage on the cluster where the job is running, but that load on the remote name node, it might not be significant, but it's from our metrics perspective, it's pretty invisible. And so Hadoop has a tool called inintop that kind of like the Unix top tool will show you the top users and counts for each name node operation type. So we've been collecting that data for a while, and I think we're about ready to be able to give that a slice of that platform cost, and maybe it'll be something small to start. But that way, when you're doing these kind of remote reads, it'll show up as a cost for that cluster, even though you're not running any jobs there. And the next thing is being able to include other resource types as well. I'm really interested in seeing network utilization. Through the resource-aware scheduler, we might see that in Storm first. But there's a Hortonworks talk earlier about doing more generalized kind of resource scheduling for Yarn. So we might see network utilization show up on the Hadoop side as well, or something like disk IOPS. As I mentioned earlier, we have a lot more to do with working with teams through these kind of metrics to identify ways we can save. And one of the things, we have a tool called Downsizer that analyzes a user's jobs and looks at their peak container usage over the lifetime of the job and compares it to the size of the containers. And so, and you can look at all of your runs of the same job over a period of time and get those averages. And we'll come back with a recommendation for an ideal container size for you. And we'll let you choose, your own safety net. If you're revenue bearing and failure means we drop money all over the floor, then you can select, a larger, maybe a 25% or 50% safety net. If you're not, you might choose a smaller safety net. And so we can kind of do more of that squeezing as much as we can out of our clusters as possible. And also, at the end of the day, all of this is kind of is meant to enable us as a company, if we wanted to move to an OpEx model, where our teams and business units just pay for the resources they use, rather than needing to divine what they might possibly maybe will need 6 months or a year in the future. I think in the ideal world, we could run our large private clusters as if it was, a public cloud. I want to thank everyone for coming, and I especially want to thank some of my team members, Shauna and Alessandro, as well as our Hadoop dev team and SE teams that have helped out with this process along the way. And I'd be happy to take any questions if you have any. Yes?
A couple questions.
Sure.
So how big of a team do you have that's working on creating these tools and doing this?
Right now, 2 people. So, and when we're spread out about, and this isn't all we do a variety of other kind of things too. So I'd say, maybe 50% on the cost and resource tracking side, and maybe 50% is, cluster management, access management tools.
And you built your own tool, so there wasn't any tool like that is like this out there that you guys saw.
So there's a lot of really awesome tools out there, and so our problem is usually scale. I've seen a lot of things over the last week that I'd love to be able to harness. But I haven't found anyone that says, sure, I can do that for a 6,000 node cluster. I think, I think scale is probably our biggest challenge for using any of the other tools. I think, I'd be really interested in looking at some of those tools if we were at a smaller scale. But we really don't even have many clusters that are less than 1,000 nodes. So.
And then last question. So have you found that this has helped the teams be better citizens of the cluster, or are they just more like, oh, well, my stuff's good and I don't have to worry about anybody else?
It depends on the team. I think some teams really took to it and through it decided, like, oh, we really want to drive this down, be as good as citizens. In other teams, you're with kind of the owned and operated cluster, there's always this kind of entitlement mentality you're running against, where it's like, well, I funded these in servers, so it doesn't matter if I use them inefficiently, they're my in servers. And so I think through these kind of things, we're trying to break that mindset.
Okay, so each department funds a certain expansion of Hadoop or a certain cluster then? Current.
Just parts of a cluster. So the clusters are multi-tenant, so they're not owned by individual business units. But when a project comes on, like say right now, there is this capital allocation kind of process to get approval. But I think if we were able to move to an OpEx model, it could be a lot more agile, a lot easier, and I think it would drive people to be better grid citizens. Yes.
So you said you built your own tool because of scale.
Yes.
Can you name one of the other tools that you liked that would be good for maybe smaller 100 clusters?
Off the top of my head, I'm blanking on the name. No, I'm blanking on the name of the one I was going to think of. We've looked at things over time, and like say, generally it's always kind of run up against that scale issue. So,
are you guys going to make Doppler and this kind of stuff an open project for?
So kind of that's one of the things I wanted to gauge if there was interest.
Yes.
I don't think there's any reason why we couldn't open source what we've done. So, yeah. Yes.
Yeah, so with all this data that you collected, what's your backend database or data storage?
So right now we're still using a relational database. So we use MySQL for the backend for this. And we do a lot of optimizing of our queries so that, I'd say our metrics tables, some of them are on, approaching, I think 300 to 400 million rows, but yet we're still able to get, get those dashboards to get results in, 10 milliseconds. I think some things we're going to be doing in the future are going to push us towards more grid-based technology. We'll probably be shoving some things into HBase later this year. Yes?
What constitutes a project? Like, how would you actually tie it up with queues or users or IDs?
Yeah, that's a tough one. And that's one of the challenges with being as big as we are. Even internally, the definition of a project really varies. And so in trying to make this, one of the things that was hard was to nail down, well, how can we define a project and roll up to a project level. And so where we've had to do it is say, a project is one or more unique users. And then on the storage side is one or more top level project directories. And we can date range things. So you can say this user is on this project between these dates and this project between these dates. But you shouldn't be overlapping at the same time. And one side effect of this is we do a lot with headless users. And part of that is just so that anyone on the team can jump in and fix and manage things that project's running. But a different approach you could take would be if there was a way to tag your applications with kind of like a project ID, which like I say, I had a Jira in the past for doing that, but I think going the headless user and user-based route kind of won out is the easiest approach.
You say headless user, you mean like a system account?
Yeah.
Oh, okay.
Yep. Yep. Yes.
Have you looked at timelines of V2 and see how much overlap there is?
So that's something I want to look at pretty soon. Yep.
Which one?
Timelines over V2. So. I mean, I guess the why not is, it comes back to that small team, and we have a huge backlog of things we want to work on, and so, open sourcing something is going to take some of that time, and so, not feeling like we have the room to do it.
But we all raised our hands.
That's right. So yeah, that's right. My boss is here somewhere, so he saw that. So. Anything else? Sure.
So in this case, you're only looking at the cost for the resource. And if you look at the performance, like just look at if the cluster is deployed, for example, certain parts, do you have any capability to do that?
We're focused just on the resource utilization and cost. We don't have. I think that would be a piece I'd really like to see in the future. Is to have an SLA component and performance tracking, but we don't really have much in that way today. It's kind of on the individual teams to do that, and part of that is our workloads are so varied that it's hard to come up with something general that meets all those needs.
You had like a tag on one of the Dopplers. Was that on a certain version upgrade that happened, or is that like, hey, we deployed a new application?
Oh, okay. I think I gotta get off the stage. We're playing the music, but I'd be happy to talk to people up front.